Hello friends. In last class we have studied about the resistance and we have seen the properties of resistance. So we will start next from this topic. So first of all we will revise the last class. What is resistance? Actually we have studied that resistance is the property of any conducting material which oppose the flow of current. And we have discussed in last class that it is depending on the length and area of cross sectional, and we have studied that it is also depending on the temperature. So we have discussed all these factors. Now we are going to start with the next combinations of resistor. So now our topic is combination of resistors. If in previous class we have studied about resistors, if I take two different type of resistors, means they are made up of different materials, then if we combine both of those resistances, then how the cumulative effect will be shown. Means if I combine two resistors, suppose this is resistor 1 R1 and this is resistor 2 R2. If I combine both the resistors, then in which fashion I can combine both these resistors? Means there may be two type of combination. One is series combination and another one is parallel combination. So first of all we will discuss about the series combination. So how series combination can be formed? If we joined these two resistors in such a fashion that the end point of first resistor is connected to the starting point of second resistor. Means suppose this is resistor 1 and this is resistor 2. Now this is the starting point of first resistor, this is the end point of first resistor, and this is the starting point of second resistor, and this is the end point of second resistor. And now what did I said? In series combination, if the end point of first resistor is connected to the starting point of second resistor, then the combination will be called as series combination. So, and next the parallel combination. Next we are going to start with the parallel combination. Means, and if I connected, sorry, in series combination we can have some more points, that if I connected three resistors like that, then I want to connect these resistors in series, then how may I connect? End point of the first should be connected to the starting point of second, end point of second should be connected to the starting point of third, then the resistors combination is called series combination, like that. Now we are going to discuss with the parallel combination. How may I form parallel combination? So next topic is parallel combination. We have discussed that series combination is the combination of the resistors when we connect them by the starting point to the end point, like that. And now we are going to start with the parallel combination. How parallel combination may be defined? Means if we take two resistors, suppose this is resistor 1 and this is resistor 2. Now suppose its value is R1 and its value is R2. Now if I connect, this is the starting point of first resistor, this is the end point of first resistor, this is the starting point of second resistor, and this is the end point of second resistor. If I connect starting point of first resistor with the starting point of second resistor, and if I connect starting point of second resistor with the end point of end point of first resistor with the end point of second resistor, then the combination will be called as parallel combination. This overall combination is called parallel combination. And if I take three resistors, then how may I connect them in parallel combination? Suppose I am taking three resistors like that. Means both or all these three resistors, the end point is connected to a single point like that, and starting point is connected to a single point like that. Then and it's there, these values are R1, R2 and R3. So we have connected the starting points together and end points together. The combination is called parallel combination. So Now we are going to discuss the equivalent resistance. So when we are connecting those two resistances in equal manner or in a combination, then how the combination will be formed, or the what will be the equivalent resistance, we will discuss about the equivalent resistance in series and parallel combination. So next topic is first, in series combination we have seen that the combination formed will be like that only. If I connect a battery with the two ends of this combination, suppose this is the battery I connected, V volt battery, and its value is R1 and its value is R2. Now when I connect this battery with the combination, then due to the connecting the battery, a current will be flown in this from this battery, and what will be that current? Suppose that current is I. Now this current will go from this way and it will continue in this way and it will go in these resistors, and if I calculate or if I see that this is the end point of first resistor, and if this current is coming from this resistance like that, now it will come at the junction point. Now it will see that how many ways it can go. It can go only in one way, because at this end or at this junction it has no other points or no other way to travel the, so it will go in resistor 2. Means in series combination the current is same in the whole combination. So the equivalent resistance may be found how? By applying Kirchhoff voltage law. V is equal to I into R1 plus I into R2, means potential drop across the resistance 1 and potential drop across the resistance 2. So how may I connect these two? V equal to, suppose this is the resistance 1 and this is resistance 2. So when I will, how will I, suppose potential difference across the resistor 1 is V1 and potential difference across the resistor 2 is V2. So V equal to V1 plus V2 लिख सकता हूँ, and so I can write V equal to V1 plus V2. And how may I can write the value of V1? V1 is the potential difference across resistor R1. So value of V1 according to Ohm's law will be I into R1 plus value of resistor and what potential difference across the resistor V2 is I into R2. So how it can be? I into R1 and I into R2 is equal to total V equivalent, and V equal to, if I take I common from this relation R1 plus R2, now divide the resistance, divide this voltage with the, now divide this voltage by current. So V upon I is equal to R1 plus R2. So this combination may be written as R equivalent. V upon I is according to Ohm's law R. So R equivalent is equal to R1 plus R2. So when I connect two resistors in series, then this is the equivalent resistance formula. If I connected more than two resistors in series, then what will be the equivalent resistance formula? R equivalent is equal to R1 plus R2 plus R3 plus dash 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 dash, means how many resistors I am connecting in series, they may be added directly. So we can have a small example. Let three resistors are connected in series, then find their equivalent value. The value of R1 is equal to 10 ohm, R2 is equal to 5 ohm, and R3 is equal to, how may I find the equivalent resistance value? Means first of all I will combine these in series. Series में कैसे, how I can combine these resistance in series? Means this is the resistance 1, this is resistance 2, and this is resistance 3. I am connecting in series like that. R1 is 10 ohm, R2 is 5 ohm, and R3 is 20 ohm. So R equivalent will be equal to 10 plus 5 plus 20 is equal to 35, means R equivalent is equal to 35 ohm. I can find it like that. Now if I want to find now if I want to find or current in these, so I have to connect a battery across these two resistors. So example 2, suppose I am taking resistor 1, this is resistor 2, and this is resistor 3, and their value is 1 ohm, 2 ohm, and 3 ohm. Then if I connect a battery across the combination of 12 volt, then I want to find current in the circuit. Second, I want to find potential difference across each resistor. Then to find the current, I will apply Ohm's law. Suppose current I is flowing in this wire, then the whole battery will be equal to, suppose the potential difference across this is V1, suppose the potential difference across V2, and this is V3. So how can I find V1, V2 plus V3? 12 volt will be distributed across these three resistance. Then how I can find the value of resistance voltage difference across V1? I into R1, means potential difference across the resistance R1 will be equal to I into R1. According to Ohm's law, we know Ohm's law is equal to I into R1 1 ohm plus, according to Ohm's law, voltage difference across R2 is I into 2 plus 3 into I is equal to 12. 12 is equal to, take I common, 1 plus 2 plus 3, 6. I is equal to 2 ampere. Now potential difference across resistance V1 and V2 and V3, I can find the value of V1 is equal to I into 1, so 2 into 1 is equal to 2. The value of potential difference across V2 is equal to I into 2 is equal to 2 into 2 is equal to 4 volt, and voltage difference across resistor R3 I3 is equal to I into 3 is equal to 2 into 3 is equal to 6 volt. That is the answer.